The intermediate value theorem for functions says if a function is continuous on the interval from A to B, then all the y values from f of A to f of B are used. The intermediate value theorem for derivatives just says if A and B are an interval basically on which a function is differentiable, then the derivative will take on every value between f prime of A and f prime of B. So it's really like the same thing as the intermediate value theorem for functions, except for they're talking about the values of the derivative, which just means that if the function is differentiable on that whole interval, then every point in between A and B has a derivative. That's really all it's saying. It doesn't really come up that often, but it's one of those things that when you get to a story problem, if you wanted to say, well, how do I know the derivative exists, or if they ask you how do you know the derivative exists, that's how you know, because the intermediate value theorem says it's true. The other big thing today is how to do derivatives on your calculator. That's exciting, right? So there's this button on your calculator called inderiv. That's what we call it. And so inderiv is a numerical derivative, which means it only works if you're taking the derivative at a point, right? So if you want it in terms of x, it doesn't do that for you. And it says it will turn an approximate derivative of an expression with respect to the variable given the value at which the calculator, in which to calculate the derivative in x. Okay, so I think really old calculators, you had to say like how accurate you want it to be, because it's really using like slopes of secant lines to find the derivative using the calculator, like the program that's in it, which means that sometimes it's a little off. Like if the answer is 0, sometimes your calculator will say like 1.2 times 10 to the negative 12th, which means that's almost 0, right? And so you have to just know that sometimes the calculator is a little bit inaccurate based on the program that it's using. I think newer calculators probably aren't as inaccurate as our calculators are. So it only works for real numbers, and so here's kind of the big important thing. First of all, I'll show you where it is. Guess where it is? It's where everything is. Under math. When you hit, I think it's math 8, math, and then you hit number 8, it says inderiv. What you have to type is you have to type the function, usually it's in terms of x, then you have to say with respect to what variable, which is normally x, and then you have to say where do you want it to take the derivative. So let's just say I wanted you to find the derivative of f of x equals x cubed minus 2x plus 1. And I wanted you to find the derivative, I wanted you to find f prime of 3. We could do that using the limit definition where we plug it in and we do either the limit as x approaches 3, or we can do as h approaches 0 and work it all out. But your calculator will also do it for you. So if you hit math 8 inderiv, you're going to type that function in, just this part. So remember that x is up there, like the x comma whatever at the top. You can do, I think there's a cube button somewhere, but I always just use the caret, so x cubed minus 2x plus 1. You have to tell the program, right? It's just a program in your calculator. You have to tell it with respect to what variable. So you have to hit comma, right? I've always wondered why there was commas on your calculator. Comma is up above the parentheses, right next to the parentheses. Right above 7 is a comma.
Just so I create demonstrated.
And you have to hit x there to say do the derivative with respect to x, and then you put another comma, and you tell it where you want to find the derivative, which for this one we're going to say 3. Close your parenthesis and hit enter, and it should give you an answer. 0.000001? Right, well yours looks nicer. Yours looks like the calculator speak, right, that we use. So his says this, ddx, all right, you have to fill this in with the x. Is that true? And then he types his function in, and then it says like x equals or something, right? And then he fills it in. Like his actually looks like what we write out. We would write find the derivative of the function with respect to x of that at this point. And ours is old school. That's true. Did you get the same answer?
Step 6 decimal places is 45. 0.00000.
45 5060.
5 zeros.
Oh my goodness.
You got that too, but there's one five in front of it.
Oh, it's 25. Oh, yeah, yeah. I think it should just be 25, I bet. Here, I'm gonna do some cheating, don't look.
But I forget it says surface. Which way?
Yeah, it's supposed to be just exactly 25. I just did it the cheating way that I'm gonna show you tomorrow. Which means the real answer, if we actually do this, is just 25. So just know that all this is just calculator speak. Okay? Calculator speak. Okay? Oh, look, so you do this one. Use the function f of x equals x squared plus 3 at the point x equals 2, and it says, like the book says this, use a calculator with h equals 0.001. The AP exam never says use h equals blah blah blah. Also, your textbook will say use inderiv, or no, what do they use? They use, this is what it says in your textbook, use NDER, which I think is even older, or maybe different calculators speak. And the AP exams are never going to say use inderiv. They're never even going to tell you when you're supposed to use a calculator, except for half the test is with a calculator and half the test is without. That you just have to know that if you're allowed to use a calculator and they ask you to find the derivative at a point, you're allowed to use your calculator. That's why half the test is without a calculator. What did you get? 4? 4. 4 is the right answer. Anyone not get 4? Okay. Be aware that sometimes your calculator will give you an answer even if it's not differentiable. And again, that all comes down to the programming because it's not doing the derivative the same way that we do the derivative. Which means if there's a sharp corner, or if there's a cusp, or if there's a vertical tangent line, your calculator doesn't know that. So sometimes you have to use your brain and not to always trust your calculator to think about it. So look at this one. You find the numerical derivative for x to the 4/5 at x equals 0. Remember what we talked about on Friday about stuff to like the 1/3 power and 1/5 power? But go ahead and type it in and tell me if the calculator gives you an answer. I'd be interested to know, Bradley, if yours gives an answer. Or if it's smart enough to know now that there's not a derivative here. It says 0, right? So if you do inderiv and you type x, and again you would just do caret, parentheses 4/5, comma x, comma 0. It says 0. Now go to y equals and graph that function. So graph x to the 4/5. I'm kind of all zoomed in here, but it appears to be either a corner or a cusp. You see? And so this is not true. All right? So the answer here is actually it's not differentiable at x equals 0. But know that your calculator can give you the wrong answer. So just be aware of that. All right? I don't think the AP test would ever trick you. On the AP test, on the part that they give you the calculator for, it's really awful functions that they give you the calculator for that, like something like this isn't that hard to differentiate once we learn the rules this week. But just know that that can happen, and so just be aware of it. I do want to tell you that there's one other place that you can do a derivative on the calculator. So if you're on your graph right now, so if you have it graphed, and you hit calc, right? So if you hit second trace, which is actually the calc button, right? That's where we go to do x-intercepts or zeros and max and mins, right? Number 6 is derivative, and it's kind of cool because if you have the function graphed and you want to see like what is the slope at this value, which we'll show you since we have this one graphed and it's incorrect. If you type in 0 on number 6, so if you hit second calc and number 6, it asks you for, like just type in x equals 0, or just type in 0. 0 at the bottom. And it should show up at the bottom, dy dx equals, and it also says 0, which is also not true. Did you see that? So hit calc 6, and then just type the number you want. And then hit enter. And it says dy dx equals 0. And so you might be, it has to be in the window in order for it to work. Does that make sense? So like if you type in 0 and it's not in the window, then it's not in the window. So now click on the second count. 6. 0. So now hit 0. I'm just not sure. Okay? So today's homework should be kind of easy because most of it is using a calculator. And it does say is a differentiable at the point, which means they're going to have you do something that give you the incorrect answer on purpose to have you check to see is a differentiable. So you're doing 17 through 25 odd, which are all using your calculator. And then 38 and 39A are talking about is it differentiable or continuous. 38 is using the button on your calculator. So you actually probably could get this done if you just do it really quickly. If you still have test correct